Welcome to Tech Bytes and News, your daily roundup of articles featured in Hacker News. Today, we're diving into a fascinating project, Wild, a very fast linker for Linux. It's generating quite a buzz. And for good reason.
A new linker? That's exciting. I've heard of Mold, which is already pretty speedy. What makes Wild different, and why is it needed?
That's a great question. Mold is indeed fast, but it doesn't currently support incremental linking. Wild aims to address that. The goal is blazing fast build times, especially crucial during iterative development. Think about how much time you spend recompiling during development. Wild aims to drastically reduce that.
So incremental linking is the key differentiator? But it's not implemented yet, right? What's the current state of the project?
Exactly. Incremental linking is the long-term goal. But even without it, Wild is already significantly faster than other linkers in many scenarios, especially for non-incremental linking. It's written in Rust, which is believed to make implementing incremental linking more manageable. Currently, it supports x86-64 Linux, and it's usable for development purposes. They've tested it with many popular crates on crates.io, and it seems to be working well.
Impressive. So how much faster are we talking? Do they have benchmarks?
Oh yeah, they do. Their benchmarks, run on a pretty standard system, show Wild significantly outperforming GNU LD, Gold, LLD, and even Mold, especially when linking without debug information. For example, linking Rustic driver without debug info, Wild clocked in at 486 milliseconds, compared to Mold's 946 milliseconds, and GNU Wild's whopping 20,774 milliseconds. That's a massive difference.
Wow, that's a huge speed up. But what about with debug info? Real-world development usually includes debugging, right?
You're absolutely right. With debug info, the performance advantage shrinks. While still faster than GNU LD and Gold, it's closer to Mold and LLD. The developers acknowledge this and are working on improving performance in this area. It's still early days for the project, remember.
I see. So it's not a perfect replacement for existing linkers yet, but it shows incredible promise. How easy is it to use?
Relatively straightforward. You can install pre-built binaries from their releases page, or build from source using Cargo. To use it as your default linker for Rust, you just need to add a few lines to your ~e/.cargo/config.tomtomstall file. It leverages Clang, so you'll need that installed.
And what about verifying that Wild is actually being used? How can you be sure?
Good point. You can use readelf to check the .comments section of your executable. It'll show you the linker version if Wild was used. Or, if you don't have readelf, a simpler method is using strings to grep for linker.
That's handy. So overall, Wild seems like a very promising project. It's fast, even in its current state, and the potential for incremental linking is huge. It's definitely worth keeping an eye on for developers who value fast build times.
Absolutely. It's a testament to the power of Rust and a great example of how open source innovation can significantly improve developer workflows. The project is actively developed, with contributions from several developers. Remember to check out the GitHub repository for more details and to contribute if you're interested. And that's all the time we have for today's Tech Bytes and News. Thanks for listening, and goodbye.
Bye-bye.